interpreting logistic regression coefficients. Now again, if we redraw the probability graph that we got through logistic regression, we'll end up with an S-curve that we've already discussed. Now let's compute the predicted log odds for AL equals 2 using the equation that logistic regression scikit-learn object has given us. So we'll take the intercept, we'll multiply the value of AL with the coefficient for that column, and then we try to look at the log odds. The log odds in this case turns out to be 0.64. If we want to reverse that to probabilities, then all I have to do is come to odds from log odds by taking the exponential of the log odds. Done. And I know the probability is related to the log odds through a relationship where probability is equal to odds by 1 plus odds. So I do that and get my probability. So in this case, I get a probability of 0.65. So when AL equals 2, the probability that the glass type will be of household is 0.65. That is the interpretation of the output of logistic regression. So instead of doing all these arduous calculations by ourselves, getting the log odds, taking the exponential, calculating odds by 1 plus odds to get the probability, of course scikit-learn has a convenience method that we've already seen, predict underscore prob A, that gives us the probability values, and we'll just skiv off the second column of that output to get the same probability that we hand computed. So if I now want to examine the coefficient for AL, I get a value of 4.18, and the interpretation of that is a unit increase in AL is associated with a 4.18 unit increase in the log odds of household. So this tells us that increasing AL by 1 increases the log odds by 4.18. So in our previous example, we took AL to be equal to 2, and this time if we take it equal to 3, we'll actually get a probability of 0.99. And since we knew that interpretation that a unit increase in AL will result in 4.1 increase in log odds, we manually increased the log odds by 4.18, took the exponential, calculated the probability, and this is the same probability that scikit-learn is outputting when we do a predict underscore prob A with an AL value of 3. There we go. So the bottom line being, positive coefficients increase the log odds of the response and thus increase the probability, and negative coefficient decrease the log odds of the response and thus decrease the probability. So let's examine the intercept, and the interpretation of the intercept is, for an AL value of 0, the log odds of household is minus 7.71. Converting log odds to probabilities. So if I assume AL to be equal to 0, then I don't have to calculate any coefficients whatsoever. I can just take the intercept to be the log odds, take the exponential, do an odds by 1 plus odds to get the probability, and I get a probability of 0.0004. So in this case, what we're trying to say is, if the value of AL equal to 0, the probability that the class type will be of household is 0.00044. Now this makes sense from the plot above, because the probability of household equal 1 should be very low for such a low AL value. Changing the beta 0 value shifts the curve horizontally, whereas changing the beta 1 value changes the slope of the curve. So if we take a look at the plot on the left hand side, we are just trying to come up with different plots with different beta values. So the black line is the line when beta 0 is equal to 3. The blue line is when beta 0 equals 0. And the red line is when beta 0 equals -2. And see how changing the beta 0 just results in shifting of this S curve, and all the other things remain constant. Now, if I were to mess around with the beta 1 coefficient instead of beta 0, I will get a plot that looks something like on the right hand side. So if beta 1 is assumed to be 0.25, I come up with the red curve. If beta 1 is assumed to be if beta 1 is assumed to be minus 0.25, I come up with the red curve. If beta 1 is assumed to be 0.25, I come up with the blue one. And if beta 1 equals 0, I come up with a more steeper, more vertical looking curve that I get on the black line. So in this section, we went through interpreting logistic regression, what they output, what are log of odds, taking the exponential to get the odds, calculating odds by 1 plus odds to get the probability, confirm how scikit-learn's predict_prob does the same thing for us, interpreting the coefficients of the logistic regression model, and finally interpreting the intercept of the logistic regression model, finally putting it all together to get how the behavior of the logistic regression model changes if one of them is messed around with.